Hello guys, today I will solve the question validate binary search tree. The question number is 98 and the question type is medium 1 and the question statement is given the root of a binary tree, determine if it is a valid BST or not. And what is BST? It says the left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both the left and right subtree must also be a binary search tree. So first we will see what is the question, then I will also explain what is BST. So let's see what is the question statement. The question input will be like this. What is this? The first value of this root of this array will be the root of the tree, first base root, and after first digit that is 1, that is second digit of this root will be the left child of the base root, and 4, that is the third digit of this root, this array will be the right child of this subtree, and the null, this will be null, this will be null. So it is stepwise, like first this step left to right, then left to right, then left to right. Input will be like this: 5 1 6 null 3 6, like this, left to right. And output we need to give whether it is BST or not. If it is BST, then we need to return true, otherwise return false. This is the boolean function where we need to return either false or true. So let's see what is BST first. So here it is 11, right? 11 is a base. It says its left child should be lesser than this root value, right? It is lesser than root value, that is 7, and right should be greater than root value, that is 12, right? And there is also a point, like all these values should be lesser than this root value because it is left. What our BST says, the left subtree of a node contains only nodes with keys less than the node's key. It means that the left subtree of this node, all these nodes value should be lesser than this 11, and all these right side value should be greater than this 11. You must be wondering why it is 4 here, because it is wrong. It is just an example, it is showing that it is wrong. So here if we can see 7 is lesser than 11, right? So it's right. 5 is lesser than 7 and also lesser than 11, so it's right. And 9 is greater than 7 and lesser than 11, so it's right. 8 is lesser than 9 and greater than 7, it's right, and lesser than 11, it's right. And 10 is greater than 9, greater than 7, because it is the right side of the 7, so it should be all greater than 7, so it's right. Here in the right side 12 is greater than 11, so it's fine. And 4 is lesser than 12 but not greater than 11, right? So it's false. 13 is greater than 12, also greater than 11, but 4 is not greater than 11, so it's wrong. So what we can do for solving the question, so let's see this example also. Like 3 is lesser than 8, 10 is greater than 8, right? Fine. 1 is lesser than 3 and lesser than 8, so fine. 6 is lesser than 8 and greater than 3, fine. 4 is lesser than 6 and lesser than 8 and greater than 3, fine. Here all these are fine, but these two are lesser than 6 but not greater than 3, right? But lesser than 8, not greater than 3, that's why it's false. So what we can do? We can do one thing. Let me show you. You know why it is called binary search tree? Because we can search like a binary, binary search. So we can do one thing. We can arrange this tree in ascending order. You know how? If you will see, the left subtree of this 11 is always lesser than 11, right? So left subtree of 11 is 7, and the left subtree of this 7 is 5, right? And the whole right part is greater than 7, right? So the base, that will be leaf part will be always be the lowest leaf part, left side of this leaf base, and the leaf part of that subtree, this subtree will be always lowest in whole tree, right? So we can do one thing, we can start from here. We will take a function which will call left subtree, like it will root dot left, it will call first, then that function, same function will be called again, that will also call root dot left. So when will be the root dot left will be null, we will return, and we will store this value in an array. So first time array will be 5 will store in our value, right, in our array. Now what will 5 do? When 5 will call its left side, there will be null, so it will return. So after calling the left side, first function, in the function we will call left side, second store, third right side call, right side. So first function, when we will give the input 11, it will call left side 7. That function again will start from start, and that will again call its left side 5. That function here it will be if condition, if null then return, 5 will return because it is null. So left side of 5 done, then it will store its value, we have stored here, then it will call its right, so it's also not present, so it will be done. Now this 5 was called because 5 was this left of this 7, right? So the when will be this 7 value as a root, the left side done because 5 is done, 5's all functions are done. Now it will store its value, so 7 will be stored. Now it will call its right side is 9. Now 9 is a root, right? 9 is our root. Now what 9 will do, 9 will call its left side will be 8. 8 will call its left side, that is null, so it will store itself after that calling left side. Now right is null, so it will return. Now 9's left side is done, so now 9 will store itself and it will call 10. Again 10 will call its left side and right side, left side, then store itself, then right side. So 9 is also done because 9's function left and right is called and 9 is stored, and 7 is also done. Now 11 left side is completed, so 11 itself be stored in this array, right, because 11 is called stored, and now 11 will call right side, that is 12, and 12 will call its left side. Here let's assume that let's assume that it is something 11.5, although it is not an integer, but we are just assuming because it is wrong example, it is showing that it is wrong, so let's just example 12 will call its left side, right, and again left side will be called of 11.5, it will return null, so it will store itself 11.5. Then 12 will call its right side, that will be first 12 will store itself because left side is called already, so 12 is stored and it will call right side, then right 13 will be stored. So like that it is an ascending order. Can you see all this array 5 7 8 9 10 11 11.5 12 13, it's an ascending order. Now we can take another for loop and we can see whether it is in ascending order or not. If it will not be in ascending order, we can return false. If it is in ascending order, we can return true. Let's see the code. So see, this function will be given. We will make a vector, that is just an array, and we will call this function food helper, and what will we give? We will give root and the answer is that array where we will store the value, and it is the function which will check whether it is in ascending order or not. If it is not, it will return false, otherwise it will return true, right? Now what this function are doing, this function is doing, like, if root is equal to null, that is the base case when our function will reach to the null left part, return, otherwise it will call its left part, value will be stored, and it will call right side, what I showed you here, right? Left side store, right side, and this is the base case for the leaf part. Let's see the code in our Leetcode. So it is same code which I showed you there. Okay, it's running. Thank you for listening.